Here I have a Cauchy Euler equation. It's second order. We have a second derivative. And we're going to solve this by converting it to an equation with constant coefficients. So I am going to make a substitution. And this is these substitutions are directly from the book. You can make a substitution if x equals e to the t, then t is going to be equal to the natural log of x. And to change your derivatives from y as a function of x to y as a function of t, you can make the substitution where dy over dx becomes 1 over x times dy dt, and that d squared y over dx squared becomes 1 over x squared d squared y over dt squared minus dy over dt. And so when you make the substitutions, you don't want the x in the equation. So from this first substitution, you would multiply by x, and then you get just dy over dt is x times dy over dx. That's what we have here. And so this part that's boxed becomes just dy over dt. And then on this second part, if you multiply both sides of the equation by x squared, then notice you have x squared times your second derivative of y with respect to x. And this part, on the right side, the x squareds cancel out. You get second derivative of y with respect to t squared minus first derivative of y with respect to t. So if I just rewrite this, on the right side, we don't want these log of x's, but notice that log of x is equal to t. So log cube of x, that would just become t to the third, and log of x becomes t. So this is our new equation. And I can combine these terms to get my second derivative of y with respect to t plus 2 times dy over dt minus 8y equals t to the third minus t. Here. So now I can solve to get my complementary solution, which is the solution to the homogeneous ODE, by finding my characteristic equation, which is just m squared plus 2m minus 8 equals 0. And here what we're doing is we're letting y equal e to the mt and solving. I can factor this into m plus 4 times m minus 2. And I get m equals negative 4, or m is equal to 2. So I end up with my characteristic equation as c1 e to the negative 4t plus c2 e to the 2t. We'll box that up. And now we'll find our particular solution. And the particular solution, our first guess, should contain t to the third, which is just polynomial. So it'd be a t to the third plus b t squared plus ct plus d. And notice that you don't have polynomial terms in your complementary solution. And this guess for yp also takes care of the t term. You have the ct plus d, which would be incorporated in there. So I'm going to substitute into this equation in terms of t, where you have y in terms of t. And so I have to have my second derivative. I'll find my first derivative is 3a t squared plus 2bt plus c. And my second derivative is 6at plus 2b. So substituting into that original equation, I'm going to just rewrite it. Second derivative plus 2 times my first derivative minus 8y equals t to the third minus t. So I'll substitute in and solve for a, b, c, and d. So my second derivative is 6at plus 2b plus 2 times my first derivative, 2 times 3at squared plus 2bt plus c minus 8 times y, 8 times a t to the third plus b t squared plus ct plus d is going to equal t to the third minus t. Then I'll combine like terms. I'm going to have negative 8a t to the third. And then my t squared terms, I've got here, this is 6a t squared minus 8b t squared. And then my t terms, I have 6a, let me do it this way, 6a plus 4b minus 8c, that's my t terms, and then my constant terms. So I'll do it this way, 2b, 2c, minus 8d. Okay, and then I'm going to equate my coefficients to solve for a, b, c, and d. So for my t to the third coefficients, I get negative 8a is equal to 1. And I can solve for a. To get a is negative 1/8. Then for my t squared coefficients, I get 6a minus 8b equals, and notice that there's not a t squared on the right side, so that's going to be equal to 0. And if I solve this for b, it's going to give me b is equal to 6a, which is 3/4 a. And then a is negative 1/8. So I get 3/4 times negative 1/8, which gives me negative 3/32. So b is negative 3/32. So then my t term, my t coefficients, I get 6a plus 4b minus 8c is equal to -1. And I know what a and b is, so I need to solve for c. I'm going to take this and solve it for c by bringing the a and b terms over. So I'm going to get -6a, -4b, and -1, and then divide by the coefficient of c, divide by -8. And I can cancel all those negatives out. So I get c is 6a plus 4b plus 1 over 8. And I'm going to take that 8 in the denominator and bring it to the front. I know that a is -1/8. So I get 6 times -1/8. That's 6a. And then plus 4b. b is -3/32. And then plus 1. So this gives me, I'll start back over here. C is 1/8 times, let's see what I can do here. If I cancel the 4 and the 32, that gives me 8 as my denominator. So I'll keep 8 as the denominator inside the parentheses. And I get 6 times -1 is -6. And then 1 times -3 is -3. And 1 is the same as 8/8. So I get 1/8 times -9 plus 8 is -1/8. That gives me -1/64. So C is -1/64. And then for my constant, I have 2d plus 2c minus 8d, that's 2b. 2b plus 2c minus 8d is equal to 0 because I had no constant on the right side. And I'm solving for d. I notice first that I have a 2 in common. I'm going to divide out the 2, and that gives me b plus c minus 4d equals 0. And then solving for d, I'm going to get b plus c divided by 4. So b, and I'll bring that 1/4 to the front. Let's get a new page. So I get d equals 1/4 times b. b is -3/32 plus c, and c is -1/64. So inside parentheses, I'm going to have -6/64 minus 1/64. That gives me -7/64. And multiply that by the 1/4, and you get -7/256. So D is -7/256. And from there, I get my particular solution. Actually, let me copy what I had up here. I'll bring it down here and paste it. Maybe. And so for my particular solution, I get A, which is -1/8, t to the third, plus B, B is -3/32, minus 3/32 t squared, plus c, which is negative 1 over 64 minus 1 over 64t, and then plus d, which is minus 7 over 256. That's my particular solution. And if I take that together with my complementary solution, I think that copied it. I get my general solution. Oh, it didn't copy it, did it? You go copy it again, or try to copy it. There, that's better. C1 e to the negative 4t plus c2 e to the 2t minus 1/8, not an e, t to the third minus 3 over 32 t squared. And I'm running out of space, but I know how to copy and paste, so I can bring this over here. Minus 1 over 64t minus 7 over 256. So that's the general solution in terms of t. But remember, we got that by making a substitution. Way up here. And so we'd want to substitute back to get our equation back in terms of x. So if you look at those exponentials, so I'll do this off to the side kind of. If I have e to the negative 4t, notice that e to the negative 4t can be written as e to the t raised to the negative 4th. You have that power rule for exponents that says a number raised to a power and then raised to another power, you can multiply the exponents. And you can work that rule backwards. If you have a product of exponents, you can rewrite that as a power raised to a power. So for these e to the 4t and e to the 2t, I can write them as e to the t raised to that constant power. And then where I have these t's, I can just substitute in log of x. So my general solution in terms of x is going to be y equals c1 e to the t, remember, is x. So this becomes x to the negative 4th. That e to the t becomes x. You get x to the negative 4th. And for that second term, we'll have c2 x squared. Then I have minus 1/8. And each of these t's, I'm going to replace with natural log of x. So t to the third is going to be natural log of x to the third, or natural log cube of x. Then minus 3 over 32 t squared, that's going to be natural log squared x minus 1 over 64 natural log of x minus 7 over 256. So this should be the final answer to that equation, as long as I did my arithmetic correctly.